Just settle in here. So first, welcome, and hopefully y'all found Norris okay. Since I know it was a little confusing since we've been at NI for quite a while for all these meetings. So I'm glad there's a good turnout here. So sponsors for this, for our food, it's from our revenue generated in the memberships from LastCon, memberships in the chapter that is, and then the revenue from the LastCon. So it's an important event for us, and we'll talk a little bit about that later. And facilities, NI was gracious enough to pay for this facility for us to run for today. I have to apologize for some of these slides because I created it on my Mac, and then this PowerPoint viewer doesn't like it as much. So, but this is supposed to show our leadership group, and so myself, I'm the chapter leader. I have Kate there, who is the speaker, special event coordinator. If there's any other members of chapter leadership, Josh is one of our board members as well. So if you have any questions, just reach out to us. We'll be happy to talk with you more about it, the chapter. If you are wanting to use this hour for a CPE, please just contact me and let me know so that I can provide a certificate for you. We currently have a study group going on right now. It's held at National Instruments, and they're doing the hackinglab.com exercises for the OWASP Top 10. It's been a great turnout for that, and so I can't remember exactly how far along we are with it, but Matt Pardo is, Griff, 6 of 10. Okay, so we're more than halfway through that. In terms of membership, that one you can actually read. But membership is not required to attend our meetings, but we'd just like to encourage you to see about signing up for it. And there's $50 for 1 year, and then there's some other discounts for even if you have your corporation that may want to sponsor. And then we have, as far as volunteer opportunities, we would like, if you're willing and able and would like to help out in any way, we have different things going on, and LastCon is one of our main ones. Again, we'll talk about that in just a few minutes. Also, if you do shop on Amazon.com, if you do the smile.amazon.com, some proceeds will go towards our chapter. Upcoming events. Our next Awesome Security Professionals Happy Hour is going to be on the May 12th at Sherlock's, and it'll be sponsored by Rapid7. And I know Matt Pardo has been talking about other training opportunities, but at this point, I think we're just busy with trying to get some other things done, so stay tuned and we'll let you learn more about that. And in terms of conferences, again, I mentioned the LastCon. It's going to be November 1st through 4th. And Bankham, I don't know if you wanted to come up and say a few words about it.
Sure. Hi, everybody. My name is Bankham Tejani, so I'm the conference co-chair for LastCon this year. Who's been to LastCon before? Raise your hand. Almost everybody. So there's a few of you that didn't have your hands up. Talk to someone who had their hand up about LastCon and find out how great of an event it is. It's our local chapter's application security conference. It'll be November 1st to 4th here at Norris Conference Center, so it's very convenient. It's also pretty affordable. And we're always looking for volunteers. So the whole event is a volunteer-driven event, and we still have some needs on our core team for people to take on certain activities, or if you're just interested in helping out at the event itself, we can also use volunteers for that. So feel free to contact me or talk to Griff. Raise his hand. So Griff is our volunteer coordinator. Talk to either one of us if you're interested in volunteering. And towards the end of the meeting today, we'll have a little giveaway from LastCon as well.
Thank you. Other upcoming local events, and again, this is not showing up very well, but The Cloud Austin meeting is going to be Tuesday, May 17th. ISSA, they have their meeting on Wednesday, May 18th. Austin Hackers Anonymous, AHA, is on Thursday, May 26th, and then the ISC Squared Austin chapter is having a meeting Monday, June 13th. So they have their, I just usually get these from their event calendar, so if you needed to look at more information or was interested in those other groups, feel free to Google them. And for our Austin chapter of OWASP, if you go to austin.owasp.org, you can view more information about our chapter there. And with that, I'd like to turn the presentation over to Joel Buchanan.
Well, good afternoon, Austin. It's good to be here talking to my fellow Austinites, and I'm sure there's some non-Austinites in the audience and over the phone as well. So welcome all. Pleasure to talk to you today. A few slides on data-driven application security. As the name may imply, the goal here is to try to use some data, whatever we have at hand, to try to drive some decisions about building an application security program. The great thing about data is that everybody has some. So I may call on folks in the audience every once in a while to validate the stuff that I'm going to throw at you. So I'll start with the mandatory fear, uncertainty, and doubt slide, which will, be sort of par for the course for this crowd. Does anybody who has not seen this informationisbeautiful.net, this infographic? There's a link on the bottom. A couple people. I've passed this around a bunch. Somebody sent it to me, so I sort of assume it's in wide circulation. This is a real fun site. You go to it. It is interactive and it's updated. There's actually a Google Drive spreadsheet behind it, and some wonderful person keeps recent breach data updated. These circles are names and sizes of breaches for companies in recent memory. You can see some of the names there. They also have the type of breach as well. That's the color of the bubble. So pink is hacked, as you can see, is the dominant color there. And again, you want to go check this out. It's updated. This is taken, 10 or 20 days ago. So there's new names there now, unfortunately. And there's a spreadsheet behind it, too, so you can look at the actual numbers as well. So take-home point, application security is a big problem. I'll stop there because I would assume you would not be here if you didn't believe this was true. So what are we doing about application security? One of my favorite data points is from a Ponemon survey. They did it in 2013 and they updated it in 2015. The sources are in the bottom there. I'm not sure if you can read it all the way in the back, but the slides will get posted at some point here, so don't worry about the finding links and things like that. The upper right-hand corner of that Ponemon data basically shows that when they surveyed a group of information security leaders, we're overspending on network security relative to the perceived risk versus application security, where we're underspending versus the perceived risk. So, despite the big pink bubbles on the previous slide, we're not really keeping up with the amount of risk out there from at least one standpoint. The orange table is from SANS. That is a survey of 400 plus folks that do application security, more practitioner-oriented. 43% of them think that the spending is inadequate. Interestingly, there's another nugget in there. 34% of the people surveyed didn't even know what percentage of their IT spend the application security budget was, which is always an interesting data point for me is, what's your budget? Well, I don't know. Okay. So there might be, some work to do there. There's, some classic chestnuts from Gartner. Every year they sort of re-release the 70% of vulnerabilities are at the app level. There was a quote from NIST of some interesting origin that I've never really been able to suss out. We've actually discussed this internally at Sigil. 92% of reported vulnerabilities are in applications, not networks. Again, not secrets to folks in this crowd. Probably your attack surface for an organization, individual nowadays, is applications. I don't think that's a huge secret. So, big problems, not spending enough. Beyond spending, what are we doing? This is a table from SANS as well, their 2015 Survey of Application Security, which is a good document to go check out. Again, the link is there, shortened to a Google short URL. This is a little bit hard to read from the back, but basically when they asked the 400 plus people in the survey, what do you base your application security program on? And there's another error here. If you look closely, the y-axis is kind of tweaked, so it starts at like minus 10%. Not really. I think they just sort of mistyped it. But let's say that over 50% of the people said the OWASP top 10. Great. I love the OWASP top 10. Great list. I'm not sure how you base an application security program on it. I guess you could, look for those vulnerabilities and try to eliminate them in your code, which is wonderful if you're only developing web apps and your vulnerabilities don't change year after year, and several other things that would make me ask questions about basing your application security program on it. And if you go down the list, you can see things like ISO 27034. Good standard, ISO, we all know and love 27001. For those of you that know me, I'm a big fan of the Build Security and Maturity Model, or BSIM. You can go to bsim.com. It is a now 6-year running survey of application security activities at a bunch of companies. There were 78 in the most recent survey. They update it every year. And there's a bunch of data in there. I've presented on that before. This is one slice of the data from the survey that they do every year, and I always find this really interesting. This is the top 12 things that everybody does in application security. And when I say everybody, I have it in quotes. The percentages of the surveyed companies that actually do it are noted on this slide, and they're not low. 84% of people that are in the survey identify gate locations and gather necessary artifacts. Number 12, software bugs and operations are fed back to development. 96% of the companies do that. So it seemed to me this would be a really interesting data point. What do people do in software security? Well, a lot of them do this sort of stuff. Now, the interesting thing about BSIM is that this is just 12 of 112 different activities. So there's a bunch of stuff in there. It actually gets kind of confusing when you look at it because BSIM is the entire set of data from 78 companies. So you wouldn't really go and say, well, I should do all 112 things. No, you wouldn't do everything that all 78 companies was doing. That would probably be over-investing in application security. So where does that leave us? How do we pick out the stuff that really matters? Back to the big question. What is doing application security right? Well, I've circled some stuff in this slide. And this is where my own data comes in, anecdotal experience over 10, 15 years of helping people build software security programs. You see some interesting items in this list. The usual suspects, training, security standards, security feature review, talk about what that means to me momentarily, code review, penetration testing, wow. And in fact, when you do BSIM analyses, as I've done a few of them and looked at the BSIM data set, a lot of this stuff starts to point back to some really common stuff. Let's not just ask BSIM, let's look at other data, looking at SANS again. This is a very sort of similar list from people that they surveyed. Rank the things that you find most impactful in your program. They asked defenders and builders, so there's two lists here. The lists are somewhat duplicative, as you might imagine. Look at penetration testing. There it is again. Both defenders and builders put that in the top 2. So we might come to a consensus that pen testing would be good to have in your AppSec program, right? And you see some of the other similar things here, training, code review, threat modeling. I'd call that sort of secure design review. We'll talk about that more. Static analysis, secure deployment standards and reviews. So you see standards again sneaking in there, and they even variations on standards like secure libraries and frameworks. Thou must use this cross-site scripting prevention library in your code and things like that. So combining my experiences and some data sets, you kind of get to this sort of consensus view of what is application security. And that's it. It's that simple. This is 90% of the stuff that I see people doing in application security. Now, people kind of stop there and pause. I recognize this as a really shocking list. I'm happy to define penetration testing for anybody that doesn't know what that is out there. That was a joke. You guys can laugh anytime. So this isn't rocket science, right? This is stuff that we all know and love. And I think part of my pitch here today is to try to get everybody on the same bandwagon. I'll back up a slide just for a second. So when you survey the world, right, and the BSIM deck, the BSIM data has 112 things. There's a lot of stuff. People are doing a lot of things in application security, right? SANS has got all of this stuff too. Let's keep it simple, right? We're really calling things by different names. We're doing things that we're calling something when it really is kind of that thing. This is really what I see people doing. And there's an interesting dimension of time here, too. I see people progressing. This is actually an order of the way I see people progressing. Some of these are a little off. I mean, some people will do training before code review, but it's basically correct, right? People start with pen testing. The first question is, how vulnerable are we? Well, I don't know. Let's hire somebody to break into our apps. That's almost inevitably the first thing people do. They scale up from there, and some people now assess the companies that I work with, thousands of applications a year. They have a big managed service portfolio that they run through. Code review, right? Hey, I wonder what happens. So we've looked at pen testing. We've seen the view from the outside. We've seen the dynamic view. You know, we're not feeling like we're getting everything. When we send the bugs to the developers, they say, that's an interesting finding, but that really doesn't work that way, and it's a lower risk than you thought. So maybe we should do some code review. Okay, so people start doing code review, and then they shoot off on that, a journey through various levels of scale and complexity, right? From manual code review through massive distributed fortified deployments that are churning through millions of lines of code an hour and things like that. Training. At some point, the developers, after getting pinged by all of these pen tests and code review findings, started going, hey, whoa. Why don't you guys arm us with some knowledge so that we don't have these red marks in these tests all the time? And inevitably, somebody says, hey, that's a good idea. And they start doing secure coding training. And they start trying to get ahead of the curve. Interesting, again, in this sort of progression, and this is the inherent idea here, is this idea of progression and evolution. People start trying to be proactive and get out in front of things. Standards is another mechanism to get out in front of things. After getting whacked with 4,000 cross-site scripting instances every pen test every year, somebody finally says, hey, why don't we put something out there on the old company wiki that says, thou shalt not do cross-site scripting? And we'll even link to the Microsoft anti-cross-site scripting library that they can go get for free and put it in their code. And lo and behold, we might reduce instances of cross-site scripting before we get to the pen test phase, or the code review phase. So that to me is what standards mean. Last but not least, people start realizing that code review, pen testing, what we've talked about so far is a very bug-oriented mentality, implementation-level vulnerabilities, right? And they start realizing that sometimes in those pen test things that show up that aren't really one-stop code fixes or things that they put into the defect management system and then 4 people go, fix it or not. There are more subtle problems. There are design-level security problems that are more difficult to fix and more difficult to find. It takes people that know what they're doing, that have done software engineering and progressed to software architecture to be able to find these sorts of things. So Citadel calls that architectural risk analysis, or architecture analysis is the sort of set of things that talks about doing design-level security review and remediation. Threat modeling fits into that set of things, right? So I don't want to get into sort of a vocabulary debate, but basically, again, you see this idea of progression. When people start doing architecture analysis, they tend, in main, to be playing at a sophisticated level. Now, there's always exceptions to the rule. There are some people that start with that again, but generally, this is what it looks like. I'll pause for a minute. Anything shocking, controversial here? Shaking heads. Anybody totally disagree? I don't mean not rhetorical. Throw a rotten tomato right at the screen. Doesn't work. Tried that. Failed. Awesome. Oh, wait a minute.
So say under code review.
Yes, sir.
Would at that level, in that process, would you, say, be doing a scan for vulnerabilities, say, against the NIST database, for instance, and looking for known vulnerabilities, possibly an open source that has been injected into the code?
Yes. For the benefit of the folks on the go-to meeting, the question was, would you include automated scanning within code review that would use the NIST list of vulnerabilities as input, for example? Absolutely. I don't mean to make – these things are meant to be broadly tailored, not narrowly tailored. Again, code review to me means, manual code review by your in-house expert, peer review by developers on the team that actually look at security. That's an important thing, right? I've seen peer review that doesn't. Automated analysis. In fact, a lot of folks start with automated analysis. I think more and more increasingly I see people start with a tool to do these sorts of things. Like the one that resists that, of course, is architecture analysis. There isn't a great tool out there for that sphere of stuff yet. But pen testing for sure, dynamic analysis, security testing tools, DAST. Gartner's made a name for it that we all know and love. Code review, SAS, absolutely. That fits within code review. So the answer is certainly yes. I don't mean to say, no, only if you do code review the way Joel says, do what you call it code review. No, it's, I'm just sort of flexible in the definition. Any other questions? Yes, in the back.
I understand the threat modeling from a IT risk standpoint, and I would like to know, you can bring some examples from an architecture analysis to the threat modeling.
The question was, can you give I understand threat modeling from an IT risk standpoint. Can you give a architecture-related example? Great question. Threat modeling was a term coined by a couple of folks that were working at Microsoft at the time a while back. So it actually was coined in the software security, application security world. But you're right, the concept originated well before that in the IT security world. We call it risk analysis. Software security geeks like ourselves love inventing new terms for stuff. It's just part of our pastime. So threat modeling to me is the same thing. Again, back to the tomato-tomato thing. Yeah, we could quibble about methodologies and how you execute and what kind of inputs you take and whether, risk analysis is really a superset because a threat model is just the threat part of risk, right? Yeah, there's a whole debate to have over that, which I'm happy to have after this conversation with anybody that wants to, but I won't bore everybody with that today. Suffice to say, the answer to your question is yes. The concept's conceptually the same. The idea is to apply that risk analysis methodology to software in the case of application security. The concepts are very much aligned, right? Identify the probability and the impact of something happening, rank the things that you find on paper, this is not a pen test, and then send it to the development teams or the architecture teams. Ideally, you're doing this at design time and say, hey, you should think about these things and build mitigations into your code, architecture, design the thing to prevent this sort of stuff. That simple.
I think the source code is supposed to be one.
So, I'll just talk about my employer, Cigital. In their world, their architecture and risk analysis is the next level up from a threat model where you actually will, it's better for probably implemented code where you can go deep dive into, hey, let's take this list of threats and let's go validate which ones are actually business and technical risks and build a matrix and make some findings out of it. We've actually found stuff like you'd find in a pen test doing an ARA, lo and behold. So there's overlap there too. Sorry, that was long. Somebody hit my favorite topic there. Next question.
So how does, obviously you talk about automated code review or testing practices, how does test-driven development affect and enhancing that piece of the
for the benefit of the webinar folks, how does test-driven development affect this list of stuff?
Yeah, how are you hearing
right.
new companies utilizing test-driven development practices to enhance the
great question. I actually had a slide that I removed from this deck that actually talks about that. I have to admit, I'm a little bit of a security curmudgeon. My general answer to those sorts of questions is sort of same problem, different day. And I don't mean to be dismissive at all. Test-driven development, look, agile, rapid development, that stuff's here, continuous integration, continuous deployment. We deal with this stuff all the time. That being said, I believe in this list as a set of fundamentals. Like basketball, dribble, pass, shoot. Despite what Steph Curry is doing with the Golden State Warriors this year, that's still shooting, right? He's shooting really well, but it's still a fundamental. Test-driven development, I think you're still going to do code review. Now, where you stick it in the life cycle, how you talk to your developers about doing it, do you distribute it out and space it given the fact that you've got much shorter sprints and releases? Yeah, you're probably going to adapt this a little bit. Would you not do code review? I would argue no. You should certainly still do something that smells like code review or these 5 things. Is that I don't want to seem like I'm dodging the question, but is that a fair answer? Great. Yes.
So there are I joined a company, from my experience, what I'm seeing for regarding architecture analysis is, if there is a new feature, which is going to release, we can go and we can track it and we can come up with a from this day, we can make sure that if any new feature is going to deliver, it needs to go through security and security analysis and then say, take green signal from those features. How do we tackle the old features we got implemented, those things are the things which are implementing it, right? So is there any advice for that?
So I love, see, this is the dialogue, right? Because the questions sort of answer themselves, right? Now, the order and the timing in which you do these things are important. So for the folks in the webinar, the question was architecture analysis. We have a trigger. This gentleman said that his organization has a trigger. When there's new code, we do architecture analysis. How do you go back and look at the legacy code where there's no trigger? Great question. So, and maybe this is a good segue, right? Who would agree, let's do just quick show of hands, this is the only stuff you'd have to do in an application security program, these 5 things? No hands have gone up. Great. That's wonderful. Because it turns out there actually is not only 5 things, as you have pointed out very succinctly, and I think the test-driven development question has as well. So this is a little bit of a, wink your eye and look at it sideways a little bit, and there's a little bit of oversimplification, I'm free to admit. This is the big 5 things. It's the only stuff you ever have to do. Well, not really. So turns out there's a 6th thing that I have run into in my travels, and I'll admit, it's kind of difficult to define. It's kind of mushy. Let's call it management. Management's kind of mushy, right? And I've got two sort of pieces that I've broken it into. There's actually a 3rd, but we'll get to that momentarily. And this, again, is driven off of some data and some observations that I'm going to share with you. So there's not just 5 things. There's some glue that glues the 5 things together. There's some governance and timing and policy and rules around when you do them. And we'll talk about that. So, yes, I guess the answer is it's great that you're doing architecture analysis on the new stuff. I can't tell you. Somebody asked me that question the other day. They have a corporate initiative now to go back and look at legacy code. In fact, I won't name names, but it was a customer that you probably all shop on online all the time. A friend of mine that works there that was telling me about that. Organizations, again, you get to this progression, this evolution model. You get to a certain point, and you get past the point where you're good. You're running. You're looking at new code all the time. You're getting, triggered notifications from the dev teams when new stuff is released, and you've got that stuff knocked. At some point, somebody says, hey, we should look at the old stuff. Absolutely good idea. Not to say that the big 5 only has to be applied to new stuff for sure. It's a hard question to answer because, like this organization that talked to me, they have a mound of legacy code. It far outweighs the new stuff that they're doing. So it actually, back to this idea of progression and evolution, you actually run into almost a whole new learning curve, right? You almost have more code than you kind of got through in the first 2 years once you get to that point. So not a trivial problem. But I digress. So let's get back to the 6th thing. All right, so you notice that the big 5 has a lot of assessment, pen testing, code review, architecture analysis. You probably wind up with a big pile of bugs, like on the screen right here. At some point, I think kind of to this idea of progression, you realize that you need to start making sure that those bugs are getting fixed, for one, and then managing sort of the queue, right? How do you organize the actual orderly fixing of those bugs, prioritizing them, getting the developers to fix them in the right order, reporting to people like the dev leads that, hey, you're actually fixing stuff timely or not, and people start getting into this sort of sixth thing idea. Let's see if I can advance the slide here. So the first part of the sixth thing that I want to tackle, again, this is what I see in my travels, and here's some data. And the idea here is organization. And the reason I start with organization is because, in my experience, correct me if I'm wrong, not much gets done without a human being actually going out and doing it or telling somebody to do it. So a big challenge in application security is people. Hiring qualified people, for one, right? You know, development and security in the same person is tough to find nowadays, for sure. But organizing for application security. So if you have this problem of too many bugs, you got to have people agreeing on how to address that. So how do you organize for application security? Not a rhetorical question. Well, it is a rhetorical question. There's lots of ways to do that. This data is from a study by a couple of colleagues of mine, Gary McGraw and Caroline Wong. I've worked with Caroline for a long time, many different companies. They actually looked at the BSIM data and interviewed some folks, and actually there was a session at a conference where they actually had people contribute to this. And this is a pretty busy table. I'm not going to walk through it in great detail, but basically they broke the different organizations in the BSIM into different categories. The services type approach, the services approach to organizing for application security, policy approach, hybrid services policy, business unit management, etc. The link there goes to the full article. You should go read it because they describe what those things mean. I'll foreshorten just to say very briefly here, there are different approaches between centralized and distributed control over the application security function, capabilities, tools, etc. If you look at the correlation between those approaches and the BSIM scores, which is in the second from the left column, you start to notice some things. And I want to be very careful to say the BSIM score does not necessarily correlate with good or better, but it's an interesting indicator, right? So the management organization tends to score higher in the BSIM. The business unit organization, if you go all the way over to the number circled on the right, their ratio of security people to development people is the highest in the list. If you believe that the number of security people you have in the ratio to the number of development is a good thing to be higher, then that's a good thing, right? I would tend to support that notion. The more people you have looking at the code, working on security, the better. So you start to see some interesting correlations. I'm really, again, foreshortening the article. You should read the whole thing, but the bullets here really get down to the main points. First of all, make it formal. Most of the organizations that succeed actually have somebody they call application security lead or titles thereof, right? The organization recognizes that. It's a formal role. They have a place in the organization reporting to the CISO or the leader or director of engineering or something, right? But they recognize it. Separation of duties scales better. So again, this sort of centralized distributed to really simplify the analysis that McGraw and Wong did. The centralized approach works well in the short term, but it doesn't scale too well in the long term. Many of you probably already know that. Large organizations particularly, there's a ton of software development going on. Trying to control all that from one central group gets to break after a little while. Deputize the developers. The BSIM calls it a satellite. These are people that are indirectly responsible for software security. They don't report directly into the person or the group that's in charge of it, but nevertheless, they have some matrix duties, right? It might be a security champion that lives in the development group that answers questions from the security team when they have them, things like that. That is almost as proven as an approach as you can get. The BSIM sees that every year. I saw it when I worked at Microsoft. I see it when I work with clients all the time. Last but not least, again, whenever you talk about people, human beings, organization, there are whole books written on management outside of software security. You have to adapt this to your own purposes, right? Cultures, personalities, organizations. This is, again, not to say that this is absolutely the right way to do it, but there are some principles that will hopefully help you make it successful in your org. So long-winded. I'll pause for a moment. Any questions on organizing for application security? All right, I'll just ask a question. Pardon me, chewing ice. Who has a formal application security leader at their organization that they work at? Just show of hands. All right, 30 to 50%, just roughly. That's pretty good. You're starting in the right place, right? We'll talk about sustaining that momentarily. All right, so moving on. So the sixth thing is we talked about is made up of organization. Talked about that. There's this other part of that I call integration. And this is something that I've seen, again, in my own experience. And when I ran into the BSIM data, I kind of went, wow, it's saying very similar stuff to my experiences. Application security does not exist in isolation. Again, no secret to folks in this room. The number of teams and capabilities that you have to touch and deal with and integrate and influence every day is actually quite large. So I actually went and looked at the BSIM data and some of the companies that I had actually scored and tried to quantify this. The BSIM has, again, 112 activities, and I went through and looked at the places where if you had a score for a certain activity, you almost certainly had a score for another activity because they depended upon each other. And in particular, I really looked at, again, organizational functions, right, like defect management, right? So, if you were doing code review, you almost certainly had a defect management process that was relatively mature as well, because otherwise you didn't fix stuff. So here's the result of that analysis. If you look at the percentage of the 112 activities in the BSIM that depend on these things, you sort of get this list. 25% of the activities depend on information security. So number one, if you're an application security leader or application security team member and you're not working with your InfoSec group, you're not aligning with the BSIM data, that's for sure. I don't know if that's necessarily bad or good, but it certainly is coloring outside of the lines. No secret to folks in this room. That's generally where app security originates from in a lot of my experience. Governance, risk, and compliance. If you can align yourself with people that make the rules, thou shalt comply, tends to help your program. I won't belabor this whole list. Some of my favorites, again, I mentioned defect management. If you're not tapped into or your organization does not have a healthy and efficient defect management process, the big five application security, I would argue, is not going to work for you because you're producing bugs and they're not going anywhere. So that's a key ingredient for your success and somebody that you either have to partner with or work with very closely to make you successful in app security. Vendor management, I'll skip all the way down to the list. Most of the companies that I'm working for increasingly, the way software development is done today, they don't own the code. They don't write the code. They commission the code to be developed by some outside firm. They buy the software from some outside firm. So you really have to think about applying the big five plus one or whatever you're doing in app security to organizations that you are buying code from. You have a relationship with them, but it's a contractual one. So that's an area where you really have to work with your vendor and procurement groups, legal, et cetera. It's really sort of a progression in its own right to figure out how to apply app security to third-party code. So, any questions on that? All right, moving right along. In earlier versions of this deck, I actually presented metrics as part of the sixth thing. I took it out because, frankly, I don't see a lot of companies doing app security metrics, at least at the level of maturity that I could call it deserving of membership in the big five plus one, honestly. Certainly I've worked with companies that do that, and there's probably a whole presentation about application security metrics that could be done here that would be fun. But it really is, again, it's not something that, unfortunately, today I see a whole bunch of folks doing. The reason I put it here is because, I'm knocking my head here, I just can't see how you would do something like application security, right? Formalize, somebody owns it, you're doing activities like pen testing, you're producing bugs, you're managing them, and you wouldn't measure that activity and try to use it to make yourself better. So I'm hoping that someday, in some version of this slide in the future, this deck in the future, I will be able to talk about metrics as part of the sixth thing, management, because I think it should be there. But today, honestly, we're not doing it very well. Question?
That will change as risk management develops?
Do I think that will change as risk management develops? Yes. I mean, certainly IT security is getting much more quantitative, right? SIM, big data, right? It's certainly a big trend. I think there's the same kind of maturity problems there. Frankly, we're not a discipline that is, we've been qualitative to this point, right? Red, yellow, green, and we're adapting. Everybody is. I'm adapting, everybody. So I think that, yes, I'm hopeful that app security will tag along on the larger trend of being more quantitative about risk in organizations. And I guess to be more important, not just that, but measuring your own outcomes and trying to improve, right? It's about a feedback loop, right? If you're going to do something, do it well enough to use the outcomes to drive improvement. All right. So there's a slide about metrics that really wasn't a slide about metrics. Did I actually skip a slide? No, I didn't. Okay. So I've mentioned this a few times. This slide I'll just be very brief on. 5 things plus maybe something else we could call management. Is that everything you need to know? Not really, right? The way you implement those things, we've had some good questions about legacy code, about test-driven development. There's lots of ways to implement these things. I always have looked at software security, application security as a set of principles. You can implement them in lots of different ways. The principles are important, right? They're sort of like guidelines, guardrails. Stay between them, but you've got a lot of room in the road to steer. This is an example of an implementation. It's not to say this is how you do it. This is something that we worked up for a customer of ours recently. So you can see, again, this idea of a progression, right? Starting, evolving, and mature. And you can see some of the very same sort of usual suspects, right? SAST and DAST at the beginning. Policies and processes and training kind of in the middle. Architecture analysis at the top. There's some different stuff, right? IDE plugins, security metrics, right? I mentioned that. So there's certainly things here that sort of fit in the progression that, may or may not be included in the big 5+1. But that's not to say that you shouldn't do them. So again, this is an example of taking this idea of the fundamentals, a set of principles, and evolving it and adapting it into a program that actually changes over time and gets better, which I think is the key thing. And on that note, that's probably the most important variable that I see in the data. To close on a final comment about data. If you look at the BSIM data as one source, because it's tracked organizations over time, the most important thing that you can do in application security is to keep doing it for a while. Let's look at this data here from BSIM. So this is the BSIM scores for 78 companies, and it's broken into quintiles, or 5 buckets, right? So you've got on the leftmost side, you've got the 0 to 15 bucket, those that scored between 0 and 15 points on the BSIM. And then you move across to the folks that scored the highest, right? And what does this look like? A bell curve, right? It's sort of normalized. Kind of interesting, application security imitates life. Test scores and all that other stuff that we've known and loved from growing up. So you have this sort of curve of scores. And again, I hasten to add, and my colleagues who have developed the BSIM remind me of this all the time, BSIM score does not necessarily equate to goodness, as I say in the lower right-hand corner there. That being said, I personally think it's an interesting indicator. The orange line shows you the average age of the application security programs in each bucket. So, except for the 61 to 75 bucket, where it dips for some reason, you see a gradual progression of the curve. So the older your application security program, the higher you tend to score. Interesting.
Can you read those numbers on the orange line?
Sure. So the averages are, in the first bucket is 0.9, so 0.9 years. The next bucket is 3.1, 3.9, 6.0, 5.3, because it dips a little there. Don't know why. And 8.9 in the last bucket. So on average, the folks that are scoring the highest on the BSIM, possibly a correlation with doing well at application security, have been doing it for an average of 9 years. That's a long time in application security years, in my experience, right? In fact, I should have the BSIM data. I mean, most of these folks have just started. It's a relatively new discipline. So, whatever you choose to do, and I would love for you to choose from the big 5. In fact, I would love for us to kind of get behind this as sort of a group of professionals around, hey, look, what are you doing in application security? Are you doing the big 5? Because you should be at least doing that. But even if you don't agree with that, the longer you're doing application security, the better at it you're going to get. And the idea of sustaining, we talked about going back and looking at your legacy code. We talked about metrics, right? At some point, somebody's going to come ask you about return on investment. Hey, we did a lot of pen tests last year. We paid that outside firm you liked a ton of money. Where are we actually improving? You're going to have to start showing some numbers, right? So that's probably a whole other presentation as well, is how do you sustain. We talked about starting and scaling an app security program today, but keep that in mind. The goal is to stay in business, right? Because the longer you're at it, the better you will get. And
so I had a question on that one.
Sure.
Is there a correlation between the maturity of the program and the size of the organization? I mean, could it be that larger organizations are better at this?
Darn it, I hate it when people ask questions about the data. Is there a correlation between the size of the organization and the maturity?
Yeah.
Yes, and that's why this sort of quotation marks better thing comes in. I'm airbrushing a whole bunch. I'm 78 companies that range from lots of folks to a little bit of folks, right? So there are all kinds of variables here. Size, industry, we could go on. So yes, you have poked a big hole in my data, darn it. Does the age actually correlate to better app security? By the measure of the BSIMM score, yes, it does. By any other measure, no, it doesn't. So I do want to sort of clarify that point.
But are larger organizations more mature de facto? They grow. That was more what I was driving at.
Are larger organizations more mature de facto? My anecdotal experience is yes, and in fact, the more I look at this, the more I start to think that it's like a tautology, right? People know what that is in science, right? It's something that chases its own tail. It's true because it says itself. So yes, the more mature the organizations that have been doing it the longest are better at it. Well, gee, yeah. So older organizations, larger organizations, tend to be organizations that have been around in, let's say, business, right? Private sector, public sector businesses for a long time. So they tend to have been successful at what they're doing, including software security. So yes, there is some sort of tautology redundancy to this data. I don't think the analysis has been done on this that demonstrates necessarily where size impacts it for sure, but I suspect that your answer is, your question leads to the answer that older, larger organizations tend to be on the other side of the curve. Another question.
On that note, do you have the data that any data that speaks to the larger organizations, or the better they've done it, the longer they've done it, is the result of bigger teams or more budgets?
Well, let's march back here. So the question was, do you see a correlation, if I may paraphrase, between success, larger teams, better teams, and more budget? Larger teams, more resources.
The better they go,
right.
The bigger the teams, the more budget they have to spend on.
So I'll answer in two ways. One, from the gut. My thesis today is that if you do the fundamentals, and I've asserted some fundamentals here that don't seem to be controversial, and you practice those fundamentals and get decently good at them, you will get more budget and more resources. I think that's what I see happening in organizations. Because one, they made good decisions, right? They picked stuff that was a best practice, I would argue. I'm using air quotes for those of you on the webinar. So they made good decisions, and then they worked at it, and they worked at it over time. So that tends to lead to more people and more money. That's from the gut. What actually happens, so the BSIMM has some of this data, and I've gone back to slide, let me move my mouse here, 10. You can get an idea of the scale and the different approaches at least here, right? The average number of developers in the management approach is 10,833. So that's big, right? That's the average number, by the way. So there are some pretty big fish in that bucket. And you can see that, in the business unit approach, it's a tenth of that. So you can look at the correlation of scores there, right? In fact, this is a great question. I might be able to go, sort of resort this data and show, all right, so with groups that have more developers on average, so they have higher scores. We could even look at this, right? Just comparing business unit and management, you would see a correlation between more developers and a higher BSIM score. Once again, with the caveat that the higher BSIM score may or may not be an indicator of success. So there's a partial answer to your question. Yes?
On the same note, I also think data is also drives the factor, because the ability to PCI data, then it means that we have to have PCI like data information with it. So that means that the company will be ready to invest good amount of money on security as well as to go with all the fraud and things like that.
So let me see if I can paraphrase your comment for the folks on the webinar. Some organizations are subject to regulations or contractual obligations like PCI, and that may also be a big influencer on their maturity. And PCI, if you have to have an independent firm assess you, you're large enough, so that also could be a correlator, right? Large means better. Yeah, I would agree. Again, I think this is a great comment in the front row. There are certainly other variables here like industry, regulatory, and contractual obligations that probably could balance this and might make an interesting sort of story. The BSIM does break out 3 verticals now, financial services, software vendors, and now healthcare. So you can look at their maturity relatively, and financial services and software actually tend to be very close. Healthcare is actually lower maturity in several categories. So, is healthcare more recently regulated than financial services? Therefore, that's the case. One could speculate. But yes, I think I think your point is valid. It goes to the idea that there are other variables at work here for sure. Did I answer your question? Make the comment right? Okay, great. Thank you. Somebody else had a hand up over here. Yes, in the back.
This is just a response to the question. The answer is yes. I think the previous slide where you have GRC 24% drive the aspect, 23 I guess. Mm-hmm. So the PCI, PHI, whatever the regulations, all fall under more like a GRC program, I think. So in order to meet those compliance, into the aspect, the data ultimately drives the aspect.
Yeah, I would agree with that. Again, to sort of repeat the point that, in organizations where governance, risk, and compliance have become mature disciplines, your application security program can draft in behind that. And there may also, that'll have an impact on its overall success and maturity. And I tend to agree, and this, again, is from a personal basis. So a lot of my software security experience came from Microsoft, software company, and working with startups, and so more software background, right? So I sort of come from this more, now we call it agile, and more sort of open and chaotic kind of environment. Well, when I started working for Cigital, they're more of came from the background of financial services at the time. It's grown a lot since then, but and they had this much more hierarchical, centralized sort of model or thinking around app security. And I'm paraphrasing, right? Cigital's 500 people, and they don't all think that way for sure. There's definitely different opinions. But to tell an interesting story for this group, it was kind of the worlds collide, right? You sort of had the West Coast crazy software development versus the East Coast financial services structured approach with GRC and all that stuff. This is my personal opinion, and this is anecdotal data that backs this up. And I said this earlier kind of on this slide. I see that sort of more structured, hierarchical approach that it could be, I can see why it would be successful in financial services, because the organization has that culture and those institutions, I think, to your point. Yes, that, in my opinion, that type of approach to software security would not work very well in a software company. Maybe a large software company like Microsoft that has, big institutions and a culture as well, more orderly. But in a startup, probably not. So I think you've raised, again, the great point that you're going to have to tailor all of this to your own needs. And certainly, the culture and the politics and the history of your organization are going to matter as to which one of these things you emphasize. I think you should do all of them, but whether you do pen testing to 110% of your ability and training to 20% or vice versa is kind of up to you, right? Where do you put the gas down and where do you hit the brakes? Did I go off the reservation there? Does that make sense? That whole East Coast, West Coast thing may be a little controversial. I live in the middle now, right?
Yeah.
Go Texas. There we go. Any other questions? All right. Well, thank you very much. It was fun. Good questions. I'm happy to talk afterwards for those of you that want to chat, and I appreciate the time today.